Hey guys, alright, today we're going to do section 2 in chapter 9, which is on exponential decay. So we already talked about exponential functions yesterday, and we know that they're in the form a b to the x, where a is our initial value and b is our growth factor. So when we had a value that was greater than 1 for b, that gave us what's called an exponential growth. Today we're going to talk about exponential decays, which occur when you have a growth factor that's between 0 and 1. In other words, your growth factor is some sort of fraction, meaning that you're going to get smaller every time. Okay, so depreciation, that's kind of our vocab word for the day. That's the amount of decrease in value over time. So you might hear something like your car depreciates in value by 20% each year or something. Okay, that means that it gets less and less valuable every year. So if I decrease R% annually, then the item is worth 1 minus R%. So for example, if I decrease 20% annually, meaning that I'm less valuable by 20%, that means that I still retain 80% of my value. So the item is worth 80% of what it was worth the year before. So when you see depreciation, you have to be really careful about what number you put in for your growth factor, because you have to talk about what the item's worth, not how much it depreciated by. Alright, so some used car dealers use the general rule of thumb that the trade-in value of a car decreases by 30% each year. Joe has a car worth $6,400. Write an equation that models the value of Joe's car in X years. Okay, so if I'm decreasing by 30% each year, that means that I'm retaining 70% of my original value. So if I want to write my function in the form a b to the x, remember a is my initial value, so that's going to be 6,400. B is my growth factor or my decay factor, depending on whether it's a growth or decay. So in this case, I'm going to be decreasing, and I'm retaining 70% of my value, so that's going to be 0.7 to the x. Okay, how much will Joe's car be worth in 3 years? Well, I can just plug in a 3 into that equation. And when I plug that in, I get $2,195.20. Okay, then it says Joe has owned the car for 2 years. How much was it worth when he bought it? So if he's owned it for 2 years, that means we're talking about 2 years prior, which would be -2. That's what I'm going to plug in. Okay, so if I plug that in, I get $13,061.22. Okay. Next example I want to talk about is half-life, and if you've taken chemistry before, you know how important half-lives are, and they can be a little tricky to calculate, but we're going to talk about a really easy way to do it, and hopefully you won't think these problems are too hard. You will run into half-life problems again in your math career if you take FST or pre-calc or discrete math, so you want to make sure that you understand these. Okay. First example, radium-226 has a half-life of 1,620 years. Determine an equation for the percent of radium-226 remaining in the original sample after X half-life periods. So a half-life is the amount of time it takes for half of the material to decay. So in other words, our growth factor is going to be 0.5 or 1/2, because we're talking about the amount of time that it takes for half of the material to be gone. So if I'm writing my equation in the form a b to the x, remember a is my initial value. So my initial value, if I'm trying to find a percent, I'll just say that my initial value is 100. Okay, my b value, that's my growth factor, I know that that's going to be 1/2, and then that'll be to the x, where x equals 1,620 year periods. So again, I'm just going by my half-life. My half-life is 1,620 years. So I can say that it'll decrease by half every x, where x is 1,620 years. Okay, if I start with 4 grams of radium-226, how much will remain after 5 half-life periods? Well, I can say this is going to be 4 times 1/2 to the 5th. Okay, so after 5 half-life periods, if I plug that into my calculator, I get 0.125 grams. Okay, how many years equal 5 half-life periods? Well, I know that each half-life period is 1,620, so if I multiply that by 5, I get 8,100 years. Okay, and that's everything for section 2.